Hello, my name is Shevchuk Miroslav, and I am student of the 10th grade of the college lyceum named after Yaroslav Somosil. The topic of my project is artificial road roundness based on non-Newtonian fluid. So, first of all, let's understand what a line cop is. Line cop is a technical means of traffic organization that serves to forcibly reduce the speed of vehicles. He created in the form of an element raised above the surface on the roadway. There are a lot of types of line cops, but the main one is speed bumps. Speed bumps designed by Compton and usually made of plastic or rubber and clearly marked with paint. According to UK law, they can be as high as 100 mm, so that a car has to slow down to 5 mm per hour to negate one without damage. Because they need such a significant speed reduction, they are most often used in parking lots, private roads, and in some residential areas. The study of the properties of non-Newtonian fluids make it possible to improve the means of regulating traffic. Official statistics indicate an increase in the number of accidents on the road in Ukraine since 2015. One of the biggest causes of accidents is speeding. This paper describes an artificial road roughness line cope based on non-Newtonian fluid. Advantages of using a line cope on non-Newtonian fluid is first, when hitting at low speeds, the damage to the car suspension is less than when using the classic road bumps. Second is low manufacturing costs, and third is speed of installation. Our prototype can be a profitable replacement for the classic artificial road roughness. This project aims to study the properties of a non-Newtonian fluid, the effect of line cope on non-Newtonian liquid on the car suspension. Achieving the goal involves solving the following research tasks. First is calculate the optimal proportions of components for preparation of non-Newtonian fluid to create a line cope. Second is compare the load on the car suspension when moving through the classic line cope and line cope on non-Newtonian fluid. Third is analyze the experiment. First stage of the experimental work was to determine the optimal proportions of water and starch to create a model of a line cope. We make a mixture of water and starch a couple of times with different proportions. After that, we determine that the mixture behaves like a non-Newtonian liquid in a ratio of 40:60 in favor of water to 70:30 in favor of starch. For our experiment, a 60:40 in favor of starch was ideal. The next step was to make a line cope. For this, we used a fire hose and fasteners. Fasteners were made of boards and screws. We poured the liquid into the sleeve and fixed it at the edges so that the mixture would not spill out. The dimensions of the finished product were 370 centimeters in length and 5.5 centimeters in height. The main task was to compare the load in the car suspension and mount a line cope on a non-Newtonian fluid and the classic road bumps. To solve the problem, we used the laboratory tablet Einstein Tablet Plus 2 and a sensor accelerometer, which was mounted on the car suspension. Data were obtained through the MILAPX program. We made races at different speeds with a step of 5 km per hour. To obtain more accurate experimental data, it was done 5 times. At each race, we received about the same value. The error was 5%. After that, we made a graph of the dependence of the vertical shear force on the speed when moving through a line cope on a non-Newtonian fluid and a classic line cope. The next task of scientific work was to reduce the freezing point of non-Newtonian fluid. For this, we used antifreeze instead of water. The freezing point dropped to minus 18 degree of Celsius, but the ratio of antifreeze and starch to create a non-Newtonian liquid changed. For antifreeze and starch, it was 70:30. A line coat of non-Newtonian fluid can perform speed limits in different ways. With a large predominance of starch over water, we obtain a fairly solid mixture, which exhibits the properties of a solid body at a low load. Otherwise, when water is dominated by starch, we will get a mixture that will manifest itself as a solid, only when the speed is high. So we can create smart line copes, who will limit the speed on each road differently. After all of this, we have next results. First is, after experimenting, the purpose of which was to compare the load on the car suspension driving through a line cope on a non-Newtonian fluid and the classic road bumps, it is established that the force of an impact at low speeds is twice less when passing through a line cope on a non-Newtonian fluid than a classic line cope. At a speed of 30 or 40 km per hour, there is no difference. Second is, we determined that not Newtonian liquid can be prepared by replacing water with antifreeze. The result of this replacement is reduction in the freezing point of the mixture to minus 18 degree of Celsius. That is, with the change of the starch-water ratio, it is possible to develop a line cope for different speed limits. Goodbye.